So as we've seen, we've just plotted a trend line for a time series, but we have to take into account that trends in seasonality can result in a varying mean and a varying variance over time, both of which define a time series as non-stationary. And stationary data sets, on the other hand, have a stable mean and variance and are therefore much easier to model. So what we'll do for this section 3 is take that same time series, but remove the trend that we saw in the time series. So we'll compute the linear trend. This time we're going to use linear regression. So there's a linear regression reducer that we're going to apply to our time series. So the line that we saw in the plot previously, we're actually going to calculate, the equation, the coefficients for the equation for that line. And then we're going to see the concept of array image that I mentioned, because we're going to have two coefficients values and one residual. So we're going to see a 2x1 array image. And we are sort of doing what we saw in a y equals mx plus b. In this case, it's, we have other characters here, but it's the same idea. For our pixel in time, we're predicting beta 0 and beta 1 here, and we're using the time information as an independent variable, and our dependent ones are going to be the NDVI value. So we're going to remove that trend by computing a trended time series and then also plot. So what we're going to see, this is like the final result. You're going to see that the red line of the trend that we saw that was a positive, it's actually going to be 0 because we're going to remove that trend for the time series. So the NDVI values that we saw for the time series are actually going to get adjusted. They're going to shift in value so that we have a trend of 0, because it is important for some applications to have a detrended time series to be able to model this phenomenon. So we're going to go ahead and open that second checkpoint. So F46B. All right. So the first part is exactly what we've done in section 2. We're just defining function. It's exactly the same. Plotting these two charts that we've seen. And then here, section 3 after checkpoint is where we start actually the section 2. So we're going to have that constant band and the time band as our independent variables for linear regression. And then our dependent variable is going to be NDVI. The time series we're plotting is NDVI, so we're going to work with it, NDVI band. So we're going to compute the linear trend, and then the resulting image will have two bands, residuals and a band called coefficients. And this band called coefficients is going to be, it's going to have two values. So it's a two-dimensional band. So what I'm doing here is defining this variable called trend. Here I have my image collection. I am just selecting those bands of interest. So for independent, it's going to be constant and time, band T. And I'm adding to this list my NDVI band as well. So here I'm just selecting the bands of interest. I'm excluding all that B1, B2, B3 bands. So just working with these 3 bands. And then I'm applying a reducer, which is actually going to be the linear regression for the time series. So I use the function reduce, and my reducer will be linear regression. And here I have to define the number of independent variables first. So I just do independent.length, which is going to return me 2, and then 1 because I only have 1 independent variable. And then I'm adding that to the map. This step is not necessary, but I'm just adding this image to the map so we can use the inspector and actually see the array image, so the 2 values in the coefficients band. So this is where we are actually doing the linear regression. And we can see it's pretty simple, right? It's just 2 lines of code. Then what we're going to do, because we have that 2x1 array image, this next set of lines is actually one removing the residuals information, so removing the residuals value of for each image, each pixel we have, and we are flattening our coefficients band because it's 2 by 1. We're going to just turn that into an image with 2 separate bands, so 2 individual bands, instead of being one band with 2 values. That's all we are doing here. I'm going to hit run in a second, so we will see what I'm talking about. And then for computing the detrended time series, so for each image here, we're grabbing the NDVI value that we have and subtracting the NDVI value that we would see here in the linear trend. So if I open this chart right here, it's basically grabbing, for this point, we have NDVI value of 0.676. And then that detrending is basically just taking this value and removing the corresponding NDVI value from the linear trend. So this would be 0.52, this value right here. And with that, we would get a new value for NDVI, which is like removing the trend that we're seeing. And then here at the end, I'm just plotting that detrended time series to see the results. So I'm going to run this. I know it's a lot of information, so let's see here with the charts what I'm talking about. So you see that the first thing is, doing the linear regression, and we are actually adding that trend image to the map. So it's going to take a while to load. It's loading right here. This is like the area of interest where we got the images from for that specific point. The colors won't make a lot of sense right now, but that's not important. What I want you all to see is, I'll just make a click here over a point, and you can see that we have a trend array image, which is this first one where we applied the linear regression. And you can see it has 2 bands. The first one is a coefficients band, and you can see it has 2 dimensions, as I mentioned. So it has the 2 coefficients for our linear regression. Then we also have a residuals band, which contains just 1 value, so it's just 1 dimension. So this is the resulting image from the linear regression reducer. And then what we do, we flatten that image into a 2-band image. So the first step here is just getting rid of the residuals band. So we specify 0 here because we just want the coefficients band. And we use array flatten to actually turn this band, which is 2 dimensions, to 2 separate bands. So that's why here in the coefficients image, we have actually 2 bands, and it's the constant and the t, and they are exactly these 2 values that we see up here. So that's all this is doing. It's calculating the coefficients for the linear regression, for the equation, the linear trend, and then we are just modifying the image so you have 2 bands with just the constants and the t values. Now we can see also that we have this time series with the linear trend, but after we remove that trend from the time series, what we get, I'm just going to open these in a separate tab so it's easier to see. We can see this is the original time series, and these values range from 0 to 0.8. But after we remove this linear trend, we get these scaled values from -0.3 to -2. So the linear trend now is everything is 0 here. So we have this red constant line, and we have removed the trend for the time series. That's pretty much it, how to detrend a time series.